Coronavirus has infected around 16 million people in the US, with only the number of new cases still rising. Millions are being affected by the virus, including schools and workplaces, and since some are starting to open up, it can be arguably concluded that masks are necessary by everyone to help prevent the spread. Some N95 masks and even some cloth masks have one-way valves that make it easier to breathe through. But because the valve releases unfiltered air when the wearer breathes out, this type of mask doesn't prevent the wearer from spreading the virus. But what if we could filter this air?
There are two parts to the Spectrum project. The N95 masks that are currently in short supply in the US offer superior protection to COVID-19 and thus are used by medical professionals. It blocks out 95% of airborne particles with which the virus is transmitted. Cloth masks, on the other hand, that are used by the general population, are highly permeable and are only effective in limiting the spread of droplets through coughs and sneezes.
For our innovation, we reached out and asked WPI students a few questions through a survey. From the information we gathered, it was understood that these students care about the protection of the mask and the mask being sanitary. Additionally, the audience also cares about their own surroundings and would like to be aware of highly densely populated areas in order to avoid them.
We designed the mask itself in SketchUp using a design from the National Institute of Health and modified it for mounting ultraviolet LEDs for sanitizing the filter and an IR sensor for monitoring temperature of the forehead. The electronic components were too heavy for the mask, so we put them in a plastic enclosure that fits in the pocket of the wearer and connects to the mask with an Ethernet cable. A Bluetooth module connects the mask to the phone and a 9-volt battery powers the microcontroller. After printing the mask, building the electronics parts only takes about an hour, and the total cost of the mask is about $30. We bought this IR sensor from SparkFun, and it uses the principle that any object above absolute zero emits infrared light, and this principle can be used to detect a fever in real time from the mask wearer. To demonstrate this, I wired up a test circuit using a schematic I found online, and I wrote an app to display the analog to digital to temperature conversion. On the left we see hot water, and on the right we see ice water, and as you can see, the IR emitted by these objects is correctly detected by the sensor. To demonstrate the effect of UV light, we used petri dishes filled with agar as a growing surface, and sterile swabs to distribute the microbes I got from a helpful lab assistant. I then fashioned a stand from the UV LEDs and powered them on to kill the microbes in one petri dish, and kept the other one in the shade as a control. I set them under an incubator from an old incandescent light for about 52 hours. As you can see, the UV had a clear effect in reducing the number of bacteria colonies that were able to grow.
The Spectrum mask comes with the Spectrum app, which is useful for the user to keep track of their symptoms, the UV blinker, the battery of the mask, and also contact tracing. The contact tracing portion of the app displays a heat map of the WPI campus by using Google Maps and the locations of other users for the users to be mindful of the density of each building in the campus. With the contact tracing portion of the app, we were not able to go to WPI to test out real data, so we streamed locations of people in a JSON file. In the future, it would be beneficial to be able to access the number of connections through Wi-Fi routers in each building at WPI, so we can easily be able to calculate the density of each building and be able to state a max capacity to help de-densify buildings.
In this demonstration, two students are deciding to go to the Gordon Library, and the first student, with the Spectrum mask, turns on the ultraviolet light on his mask and is able to sanitize the filter. And then he goes and he opens the Spectrum app on his phone and he checks his temperature to make sure he's not contagious before he leaves. Before they go, the second student checks the Spectrum app and sees that Gordon Library is now a hotspot for the virus, decides that it's too dangerous to go, and they decide to go somewhere else.
This product of such a high-tech mask that sends information for the user's health benefits through an app can help reduce an outbreak in the future. It would be beneficial if companies could mass produce these masks to help prevent a future pandemic. And if there is such a time where an outbreak does occur, it is important to prepare now with even more advanced masks that can be produced later to help our future generations.